Hi everyone, so let's continue with the last topic under chapter 4, and that is going to be about linear inequalities in one variable. So for this particular topic, we will be graphing subsets of real numbers on a number line, solve linear inequalities, identify if a linear inequality has no solution or many real number solutions, and then of course, if we have some word problems, apply the linear inequalities as well. So in our case, when we talk about a linear inequality, it is an expression that it only has one variable, okay? And an inequality symbol, whether it's a less than or greater than, less than or equal to, greater than or equal to, is used instead of an equal sign. So inequality, linear, you only have one variable, and there is the exponent of that variable is 1. And then instead of an equal sign, you have inequalities in there. So when you are solving an inequality, it's pretty much the same as solving an equation. So pretty much we make sure that our variable is isolated so that we can get its value. And then a solution set is the set of all numbers that can satisfy the inequality. Now, one thing that is quite different with with solving inequalities is that you will be asked to represent the answers, okay? So we already know where are the numbers that are less than or greater than on your number line. But when you have an expression, so let's say we have x is less than a, all right? One thing that you have to remember, when we have the less than and the greater than, the regular ones, okay, you represent that using an open dot on that value of that x, okay? And since we are talking about the less than, there are many numbers that are less than that particular number, so we have to represent it with an arrow. So as you can see here, if it is not very clear, this is an open dot. So here, if it is greater than are going to the right, so you can see that it's going to be like this. The moment that you have your equal to symbols, okay, instead of having a hollow dot, the ones that are with the equal to symbols, you are going to use solid dots in there, shaded dots, okay? And then because they are less than, going to the left, solid dot, and then going to the right for greater than or equal to, all right? Again, main difference is if you do not have the equal to symbol, then the dot is not shaded, all right? So let's have this example. So we have all the numbers, all real numbers x that are less than 3. So if you have our number line, okay, this is 0, and then this is the number 3. So where are the numbers that are less than 3? It's going to the left. Now, when you graph it, so remember, because you are using just the regular less than, so that is going to be an open dot, and now you are going to be pointing to the left, okay? So all the numbers less than, if you will notice, this is the direction of the arrow, okay? So you can see that that's that. Let's have the next example. We have all the real number x that are greater than or equal to -1. So if you have it drawn on your graph, this is 0, -1 is on the left side of 0. And since we are using a, greater than or equal to, it's going to be a solid dot on that number -1. And then where is our direction? As you can see, it's pointing to the right. So that is our graph, okay? And then here, as you will notice, we have a two-part inequality. So -1 is less than x, and then it's x is less than or equal to 3. So in our case, okay, let's have our number line. So we have 0, this is 3, this is -1. It says here that -1 is less than x. So -1 that is less than x, less than, so you will have a hollow dot on -1. 3 is going to be a solid dot because of that equal to symbol. So there will be a 3 solid there. Now you can see that if you have this part of the inequality, you can rewrite it in such a way that x is greater than negative 1. And then, of course, the second part, x is less than 3. So x is less than 3, less than or equal to 3 is going this way. X is greater than negative 1, so it's going that way. So if you will see this two-part inequality, the graph will be a connected line with one open dot on negative 1 and a solid dot on positive 3. All right? So as I have mentioned, solving inequalities is the same as solving equation with only one exemption, okay? And you need to follow this part. When multiplying or dividing by a negative number, there is that one. Reverse the direction of the inequality, okay? If you're adding or subtracting, no changes. It is only when you multiply or divide by a negative number that you will need to flip the inequality. Okay, we do not have this rule in equations. So let's have this example. So we have 4x minus 7 is greater than or equal to 5. So again, our goal is to isolate our variable, but first we need to remove the minus 7. So we add 7 on both sides. So now we have 4x, this is now a 0, is greater than or equal to 5 plus 7 is going to be 12. And then we want x to be by itself, so we divide by 4. This now gets canceled. We divide by 4. And so our answer here will be x is greater than or equal to 12 divided by 4, which is 3. Now, if you read the question, it says here, solve and graph. So, of course, if you're going to show your graph, always refer it from 0. And then this is your 3. Is it a solid or hollow dot on 3? It's going to be a solid because of the equal to symbol. So you have a solid dot on 3, and it is going to be pointing to the right. Okay. Let's have this next example. 1 over 3x is less than 5. So as you can see here, we have a multiplier. So pretty much you have to divide by 1/3, or because it's a fraction, what you can do is we can remove this denominator by multiplying by the reciprocal. Okay, so that this 3 and this 3 will get canceled. So now we just have x is less than, okay, 5 times 3, which is 15. And again, because it said graph, so you will have 0, and then 15 is here. And then if we graph our number, 15 will have a hollow dot or an open dot. And you can see that the less than is pointing to the left. So it's going to be like this. All right, so next example here we have negative 3x is less than 21. Now, we only want x, so we know that we need to divide by negative 3. Divide by negative 3. And so now, we have, so this is gone now, x, 21, and then 3. So if we divide 21 and negative 3, we are going to get a negative 7. Now, remember, we divided by a negative number. All right. So what will happen to our inequality? This inequality is going to switch direction. Okay. So in this case, our graph, we have a 0, and this is your negative 7. Negative 7 will have a hollow dot, and now it is going to be pointing to the right. Okay. So again, whenever you have a negative number, make sure that you flip the inequality if you multiply or divide by a negative number.